Welcome everybody to the second lecture to Informatik 1. Today we will directly dive into programming and I will give you a brief introduction what we will do today. We will start with the basic programming tools which are available, namely what a compiler is and what an interpreter is and the differences between those two tools. Then we will directly move into Python and we will talk about what variables, operators, control structures and loops are and how we can use them. So one of the main questions is, how does text which we type into the computer becomes an executable program? And this is exactly what those programming tools do. So when translating source code, or in short text, the computer translates your written code into so-called machine language. And there are two different ways of translation. The first is the compiler. The compiler performs a one-time translation of your source code into a binary file. So after compilation, you get an extra file, which is an executable file, which holds all the machine language. The second way of translating your source code into machine language is done via an interpreter. And an interpreter just interprets the source code at each execution. So each time you execute the code gets translated into machine language. So the compiler translates your source code or your text into machine code. And the resulting executable file only contains computer instructions. And those computer instructions are no more human readable, which means you cannot read them. And the resulting file is saved as a binary file on your hard drive. And for example, if you have your source code file, which contains, for example, a simple print statement which just prints out hi on your computer. If you compile it, the compiler creates an executable file on your hard drive. For example, if you're using Windows, it creates an .exe file. And if you then open this exe file again in a text editor, it just shows you some strange characters, which you cannot read. And what is really important here is that this translation process happens only one time. And this process is also called the compilation process. And therefore, the computer directly executes the program. So if you execute the executable file, then the computer doesn't need to translate the file anymore. On the other hand, the interpreter also translates the source code file into computer instructions, but each command, for example, if you type in print hi, gets translated on its execution. And therefore, no additional binary file or executable file is created. So here, for example, you can see an interpreter in action. And what you will see is if we directly type in our source code, it immediately gets translated and executed if we just hit the enter command. So we start our Python and type in print hello world, and you see immediately if we hit enter, it gets executed. And same if we just enter a simple addition or a comparison, as soon as we hit enter, it gets translated into machine language and immediately executed. So we saw that the source code got translated on each execution, or in other words, at each time we hit the enter button. And this process is called interpretation. And as you might guess, this interpretation on each execution takes some time. and therefore compilers can lead to drastic performance advantages since this translation process only happens one time. So the requirements of this course are the following. You need obviously a computer which runs either Mac, Linux or Windows. So no tablet, no smartphone. And the computer should have a Python 3 interpreter running, and you should have the Jupyter Notebook or Jupyter Lab. So in this course we use Python 3. More specifically, Python 3.10 is recommended for the exercise. It offers a very good readability and also has a clear structure. As already mentioned, Python is an interpreted language and it runs on all common operating systems. And I would like to point out that if you have any troubles installing Python 3 or the Jupyter Lab, please come and visit the in-person session on Wednesday in the lecture hall. And also, please make sure that if you have any problems with your installation, please also fill out the feedback, which is linked in the installation guide, which is posted in the Teach Center. With that said, let's start with our very first programming example. And here on this slide you can see a very nice picture of a sunrise in Graz. And obviously, as in any other programming language, we will start with the famous Hello World example. Here you can see my Jupyter Lab environment where I have opened an IPython notebook called Lecture 2. And in this notebook I have prepared two small examples. The first one uses Python's print function to print out the text Hello World to the screen. And we can execute this line of code by clicking into this cell here and holding down the Shift key and then hitting Enter. And as you can see, the line got executed and the text Hello World got printed out to the screen. And you see that the line got executed here, and this one indicates that this was the first line of code which was executed within this notebook. And in Python, text is always defined within two quotes, and further, the text is always highlighted in a red color. More specifically, to text we refer in Python as strings. And we can change, for example, the text or the string to another word, for example, to test. And we can again execute it by holding down the Shift key and hit Enter. And as you can see here, this was the second line of code which got executed, and it printed out the text test to the screen. And if we remove the quotes from our string or our text and try to execute it, you see that the color changed from red, which indicates that it is a string or a text, to black. And if we try to execute this line of code, you can see that we got an error. And what this error means and why we got this error leads me directly to the next topic, namely variables. We all know variables from mathematics. And in mathematics, we use variables to store data. For example, we can write a equals to 10 and x equals to 0. And similar, in programming, we use variables to store information which can be referenced and manipulated in a computer program. And they also provide a way of labeling data with a descriptive name so that our program can be understood more clearly by the reader and ourselves. And it is helpful to think of variables as containers that hold information. So in other words, variables are placeholders, and their sole purpose is to label and to store data in memory. And this data can then be used throughout your program. And the data types define what type of data is stored in a variable. So for example, if we type in heart_rate is equal to 80, we have defined an integer variable which holds a number. And if we type, for example, my_name is equal to the string Niklas, then our variable holds a string or a text. And as already said, heart rate is a variable with the data type natural number and has a value of 80. And the variable my_name is a variable with the data type text or string and has a value with the text Niklas. So variable names should all be in English, short, clear and lowercase, and may not contain any white spaces, in German Leerzeichen. So if you have, for example, a variable name which consists of more than one word, you should or you need to replace the white spaces, the Leerzeichen, for example, with underscores. And variable names may not contain any special characters, in German Sonderzeichen. And as already said, only underscores are allowed, for example, my_name. And the following names are reserved for Python, which means that you are not allowed to use those words as variable names. As already said, variables are placeholders for values, and the assignment of a value to a variable is called declaration. So for example, if we want to store a natural number into a variable, we can type, for example, pocket_money equals to 100. And with this line of code, we have declared a variable which holds a natural number, and the variable is called pocket money. Or if we want to store a real number, which is called a float in Python, we can just type pi equals to 3.14. And with this line of code, we have declared a variable which is called pi, which holds the value of 3.14. Or as we have already done, we can declare a variable which holds a string by typing, for example, the variable name, which could be welcome_message equals to the text hi, how are you, in quotes. Or we can also define or declare a Boolean value, for example, using the variable name is_main equals to true. And with this line of code, we have stored a Boolean value, which can be either true or false, in a variable which is called is_main. And last but not least, we can also assign no values or empty values to a variable. For example, we can type a variable name, for example, empty_variable is equal to none. And with the keyword none, we do not assign the variable any specific type, but we leave the variable empty. Since we now know how we can declare variables, we can look at some basic operators which define the interaction of variables and its values. So for example, if we declare three variables, namely a equals to 3, b equals to 4, and c equals to 3, we can use a set of simple mathematical operators as follows. For example, we can use the plus and minus operator, the multiplication or division operator. So for example, we can type a plus b, which would then calculate the sum of a and b, which would be equal to 7 in this case, since a holds the value 3 and b holds the value 4. Or if we look at the second row in the table, we can use the operator for multiplication, which is the asterisk. And if we type, for example, a asterisk C, we will get the output 9, since the variable A and C both hold the value 3. We can also, for example, change the sign of a variable by adding a plus or a minus in front of it. For example, if we type -b, then Python will output, in this case, -4, since b holds the value 4. And in the fourth row, for example, you see 2 asterisks, and this means, or this is equal to calculating the exponent. So for example, if we type in p and 2 asterisks followed by a number, this means b to the power of 2. And since b holds the value 4, this is equal to 4 to the power of 2. And 4 to the power of 2 is equal to 16. And in the last row, you can see the modulus operator. And the modulus operator gives us the remainder of a given division. For example, if we type in a modulo 2, we will get 1 as a result, since the remainder of 3 divided by 2 is 1. So with the theory in mind, let's move on to some practical examples. And as you can see here, I have opened my JupyterLab environment. And here in my third example, I have defined 3 variables which hold the kilocalories of an apple, of a slice of pizza. And the third variable, kilocalories meal, builds the sum of those 2 variables. And in the next 3 lines, I print out the values of those 3 variables. And again, if I hold Shift and hit Enter, the code block gets executed and prints out the values of those 3 variables. And as you can see, the third line here printed out the sum of the previous 2 variables. And in this code cell here, I used all integer values, which means natural numbers. And in the next example, I will use floating point numbers. So again, I define 3 variables. The first one holds the kilocalories of an ice cream. And the second variable, number of scoops, holds a floating point number with a value of 2.5. So it's a real number. And the third variable builds the multiplication of those 2 variables. And again, in the last line, I print out the value of the multiplication. Again, if I hit Shift and Enter, the code cell gets executed and prints out the value of this variable, which is the multiplication of kilocalories ice cream and the number of scoops. And in this last example here, I again define 2 variables holding integer values, so natural numbers. And if I divide them and print it out, you can see that the value automatically got converted to a floating point number. So now we know how we can declare variables and how we apply basic operators on it. Now we dive into comparators, which are used to compare values between variables, and as a result, they produce Boolean values. So again, we have our 3 variables, A, B, and C. And here you can see the list of available comparators in Python. So we have the usual smaller or greater sign. So for example, if we look at the first line, if we type A smaller than B, we get the result true, since A has a value of 3 and B has a value of 4. This means A is smaller than B, and therefore the output is true. And if you look at the second line, this is A greater than B. and since A is 3 and B is 4, A is not greater than B, and therefore the result or the output is false. Similarly, we can type A is smaller or equal to B, or A is greater or equal to C, and in both cases the result is true. And if we look at the fifth row, the double equal sign is used to check if the values are equal. So for example, we can type A equal to C, and it is true if the values are the same. And as we can see, A has the value of 3 and C has a value of 3, and therefore the result is true. And I would like to point out, because this is really important, so in Python, if you type one equal sign, then you declare a variable. So then you set the value of a variable. So as you can see above, we typed A equals to 3, and there we only type one equal sign. So we declare a variable and set a value to this variable. But if we type two equal signs, this means we check if the value of a certain variable. So for example, as in the fifth row, we check if the values of those variables are the same. And in the last row, we have, for example, A is not equal to C, and the result is false because both values are the same. So this exclamation sign means not equal to. So we check if the values are not equal. So using comparators, we can produce Boolean values in Python. And obviously Python has also some logical operators which can work with those Boolean values. So for example, we can again declare two variables, namely A equals to true and B equals to false. And at this point I would like to highlight that a Boolean value can only take one of two values, namely either true or false. So there are no other values. So a Boolean value can only be true or false. And those are the most used operators, logical operators, which are available in Python. So not, or, and. So for example, we can type not A, which will produce the output false. So it will invert the value what is in A. And since A is equal to true, and if we would like to calculate not true, the output is false. Or if we look at the second line, we can type, for example, A or B. And with this logical operator, Python will check if either one of the values is true. So if A or B is true, and since A is true, the whole output is also true. And in the last line, we can type, for example, A and B. And this will evaluate or check if A and B is true. And since B is false, the whole expression evaluates to false. And for those of you who have some trouble with understanding this, I would like to point you to a YouTube video. You can watch the first minutes regarding truth tables. There all those logical operators like not or and will be explained in more detail. So again, let's dive into some practical examples. Here you can see I have again defined three variables in this code block here. So the age of Anna, which is equal to 10, the age of Tom, which is equal to 5. And then we build another variable, is Tom younger than Anna, and we assign the result of this comparison to this variable. So we compare if the age of Tom is smaller than the age of Anna. And then at the end, we print out the result of this variable here. So we print out the result of the comparison. And if we hold down Shift and hit Enter, you can see that the result of this comparison is true, because the age of Tom, which is equal to 5, is smaller than the age of Anna, which is equal to 10. And we can turn the comparison around. So we build another variable, is Tom older than Anna, and the comparison is as follows. So the age of Tom is greater than the age of Anna. And then again, we print out the result or the value of this variable here in this line. And as you can see here, it evaluates to false, which means 5 is not greater than 10. All right, so that's that. And now let's move on to a famous equation which got quite some attention in the last year. So please look at this calculation here, at this expression here. And what do you think is the result of this expression, of this calculation? And this is a division sign. So 8 divided by 2 times 2 plus 2. So I give you some time and let's do this. So, all right. So some of you maybe came to the conclusion that the result is 1, and some of you came to the conclusion that the result is 16. So let's look at this using some programming. So we define 3 variables. So the first one is A. A is equal to 8 and B is equal to 2. So it represents these values here. And then we type C is equal to A divided by B. So as you can see here, 8 divided by B times B plus B. So it's exactly the calculation in the picture. And then at the end, we print out the value of C. And let's look what the result is. And as you can see, the result is 16. So why is the result 16? Because in mathematics, we always evaluate such a calculation or such an expression from the left to the right. So we calculate 8 divided by 2, which is 4, and then 4 times 2 plus 2, and 2 plus 2 is 4, so 4 times 4. 4 times 4 is 16. So we start by the left and go to the right. The other way how you came to 1 is if you start by the right. So for example, 2 plus 2 is 4, and 4 times 2 is 8, and then 8 divided by 8 is 1. So, but this is not correct because you always go from the left to the right. And you can mimic this, or maybe all of you should learn this in school. If we want to force or to make sure that some expression evaluates first, we need to give brackets around this. So for example, if we want that the right part gets evaluated first, we need to put some brackets around the right part here. And if we do this, we get the result 1. So with the brackets, we force that the right part gets evaluated first. All right. So, and I've also showed you the exponentiation function. So with those double asterisks, you can calculate a to the power of b, and a is 8 and b is 2. So we calculate 8 to the power of 2, or in German a hoch b. And again, we can print out the result, and the result is 64. Or we can use the modulo operator. So for example, 5 modulo 2 gives us the remainder of this division. So, and the remainder of 5 divided by 2 is 1. And here, for example, I print out the result of the comparison of b is equal to b, and this is a tautology, and therefore the result is true, because the value of b is always equal to the value of b, obviously. And here in the last part, we compare if a is smaller than b, and then we negate the value, the Boolean value, and store it into the variable f. And at this line we print out the value. So let's look at the result. The result is true. So we look at it. So a is equal to 8. 8 is not smaller than b because b is 2. So this results, or this evaluates to true, to false, because 8 is obviously greater than 2. So this is false, and then false is negated here, and therefore we get true. So we already used the print command a lot to print out values of variables. So as in this example here, we can use the print command to directly print out values. So we are using only a value and not a variable. We can also, for example, store the string or a value in a variable. Like here, we store the string hello world in a variable called hello_message. And then we can again use the same print command to print out the value of the variable hello message. And also we can, for example, store an integer value, for example 250, in a variable called number of students, and then we can print out a series of variables and values in one print statement. And as you can see here, we first use the variable hello message, which contains the string hello world, and then separated by a comma, we have the value or the string wow. Then the next argument, so to say, in the print command is number of students. So this is again a variable which holds the value 250. And then the last part, which is separated by a comma, is a string which contains the value students are here, exclamation sign. And if we execute this print command with the series of variables and values, it will print out a string which states hello world, wow, 250 students are here. And as you can see here, between the variables and the values, automatically a white space was inserted. And as already said, when printing multiple variables, print automatically inserts a white space, a Leerzeichen, between the variables. So to avoid that, you can use Python formatted string literals for easier printing. And those formatted strings are string literals that have an F at the beginning. So for example, if I would like to print my name, I stored it in a variable, and also my age, which is stored in a variable. I can use Python's formatted string literals as follows. So as you can see here, there is an F in front of the quote. So at the beginning of the string, there is an F, which represents that the following string is a formatted string. And whenever I want to print out, or whenever I want to insert a variable in this string, I put the variable which I would like to print in those curly brackets. So you can see here I have hello, comma, and then the variable which I would like to print within curly brackets. And then when this statement is executed, the value which is currently in the variable gets inserted at exactly this place in the string where you put the curly brackets. And for example, if you would like to print the same using the notation which I showed you previously, you would to do it as follows. So you need to separate each variable and each value with a comma, and you see it's kind of unreadable. And what also happens is that between each value and each variable a white space is inserted, and as you can see here, between the point, the dot at the end of the sentence, there's always a white space, which we do not want. So let's look into some practical examples again. So here I have stored my first name and my last name in a variable, and then I would like to print those two variables in a string. So the preferred way of doing this is using Python's string literals. So in front of the string, in front of the quote, I put an F, which indicates that the following string is a Python formatted string. And at the place where I want to insert the variables, I put those curly brackets and then the variable name which I would like to print. And the alternative way, or one alternative way to achieve the same result, is using the notation with the commas. So I put all the values and variables separated by a comma into the print statement. So my name is, comma, first name, comma, last name. And as you might remember, using this notation, Python automatically inserts a white space between all values and variables. And another way how you can do this is using the plus operator. And when you apply the plus operator on strings, then the values or the strings get concatenated. So yeah, we can also use this method, and when you use this method, you manually need to insert the white spaces on the positions where you want them. So here we want a white space followed by our first name, and then we want a second white space between our first and last name. So let's execute this. As you can see, we got 3 times the same output. And yeah, we can also do some further arithmetics with strings, like we here using the plus operator, we concatenated strings, and using the multiplication operator, we can multiplicate strings. And in this case, we repeated this string 3 times. And yeah, so let's move on to a more, it's not really complicated, but to a more complex example. So we would like to calculate the surface and the perimeter of a square. So let's define the side of a square. So for example, the side of the square is equal to 4. And then the perimeter of the square is equal to the side times 4. So we multiplicate the side times 4. And the surface of a square is equal to the side to the power of 2. So the side squared. And then we print out the perimeter, again with Python's formatted string literals, and we print out the area or the surface, again using Python formatted string literals. And as you can see here, the perimeter and the square is equal in this case. And we can also, for example, change the value here from 4 to, I don't know, a very huge number. And again, we can execute it. And as you can see here, we immediately get the result. Another very important concept in programming are control structures. And control structures are used to control the flow of a program. So for example, in Python, we have 3 control statements available, namely if, elif, which stands for else if, and else. And an if-else statement in programming is a conditional statement that runs a different set of statements depending on whether an expression is true or false. So for example, we could say, if it is raining, then take your umbrella, otherwise else take your snapback with you. So one if block must contain exactly one if statement, and it can contain one or multiple else if statements, and it can contain one else statement. And this leads me directly to the indentation rules, zu Deutsch Einrückungsregeln, and we follow the BEP 8 standard here, which means you can write as many lines of codes as you like in the if statement. However, every intended line following the if keyword is considered inside the if. And the indentation defines the relation to the rest of the program. And in the BEP 8 standard, you need to make 4 white spaces for Leerzeichen per level of indentation. And per line, you are allowed to have maximally 79 characters. And indentation must be strictly adhered to, otherwise Python will give you an error. So it is really important that you stick to the indentation. And what is really nice about this is that it makes the code really easier to read. Let's move on to some real-world examples. Here I have prepared a little code snippet where I have stored my age, which is 16, into a variable called my age. Then I print out that I would like to drink schnapps, please. And then we check using an if statement if my age is smaller than 18. And if this is the case, we print out, sorry, you're too young, kid. And otherwise, we print out, sure, I will bring you one. So at this point, I would like to ask you, what is the data type of this condition here? So if your answer was a Boolean value, then you're right. So as we have learned, a comparison, or when using a comparator, the expression gets always evaluated into a Boolean value. And so if the Boolean value here is true, then this part of the code gets executed. And if the Boolean value here is false, then this part of the code gets executed. So the else part gets executed. And if we run this code, we see first the print statement where we would like to order a schnapps gets executed. And then we check if my age is smaller than 18. And since 16 is smaller than 18, this condition evaluates evaluated to true. And since this statement here is true, this line of code gets executed, which says, sorry, you're too young, kid. Let's move on to the next example. So I changed my age to 18 here. And again, I would like to order a schnapps. And now we declare a variable which is called under 18, where we check if my age is smaller than 18. Then we print out the value of this variable using the print statement. And then again, we check if the value in this variable is true. And if this value here is true, then we print out this. And if the value is false, we print out this. Again, we execute it. We see, okay, the first line got executed where we would like to order a schnapps. And then we print out the value of the variable under 18, which is false. Since we are 18, we are not under 18. And since this value here is false, the else part of the if statement gets executed, which says, sure, I will bring you one. And at this point, I would like also to point out some common indentation errors. So for example, here I have basically the same example as above. My age, which is 18, a print statement where I would like to order schnapps. And then again, I check if my age is greater or equal to 18. And then I would like to print out this sentence here. But here you can see I'm missing the indentation of 4 spaces. And if I would try to execute this code, you can see here that I get an indentation error, which says that it expected an intended block here. And it also gives you the point, or it points you to the code where there is an error. And we can fix this by inserting 4 spaces here. And if we then execute it, you will see that it works perfectly fine. And so we can also do wrong indentation without getting an error. So again, here I've declared my age. I print out that I would like to drink a schnapps. And then we check if my age is greater or equal to 18. We print out that sure, you can drink a schnapps. Otherwise, the waiter will say, sorry, you're too young, kid. And the waiter will offer you a beer instead. So what do you think is the output of this line of code here? So let's see what happens. If we execute this code block here, you can see first that we would like to order a schnapps. And since we are 18, we are allowed to drink a schnapps, at least in Austria. And the waiter says, okay, sure, I will bring you one. But the waiter also says, okay, can I offer you a beer instead? But as you can see here, this should not happen. This happens because we missed the indentation here. So this last print statement should only get executed if we are not allowed to drink a schnapps. And therefore, this line of code needs to get in the else part here. So we need to make an indentation here using 4 spaces, and therefore this part of the code here, so this print statement gets only executed when my age is smaller than 18. And if I now execute it again, you can see here that the last part of the code didn't get executed since we are older, or since we are 18 and therefore allowed to drink schnapps. We can also nest if statements. So for example, the waiter offering an alternative if we are too young to drink schnapps but allowed to drink beer. So for example, my age is 17 now, and again we would like to drink a schnapps. Then we can build 2 variables. The first checks whether we are 18, and the second variable holds a Boolean value whether we are at least 16, using these comparisons here. And then again we print out the values of those 2 Boolean variables. And then we build the following nested if statement. So if we are 16, we further check if we are 18, and if we are 18 we print out, okay, sure, I will bring you a schnapps, and otherwise we will print out, sorry, you're too young to drink schnapps, but can I offer you a beer instead? And since we here have already checked that we are 16, we can offer a beer. And otherwise, if we go one level up here, if we are not 16, we will print out, sorry, you're too young, kid. And if we execute this code cell here, you can see that we would like to order a schnapps. Then we print out the first variable, which indicates if we are 18, and you see it is false because we are 17. Then we print out the second variable, which indicates if we are at least 16, and this is true. And therefore the waiter says, sorry, you're too young to drink schnapps, but can I offer you a beer instead? And there are obviously multiple ways to solve the same problem. So you can solve it, for example, this way. Again, we have my age here, the two variables which check whether we are at least 18 or at least 16. Again, we print the values out, and then we can use the else if statement to do the same. So first we check if we are at least 18, and if we are at least 18, then we print out, sure, I will bring you a schnapps. Else if we are at least 16, we print out, sorry, you're too young to drink schnapps, but can I offer you a beer instead? And otherwise, we will print out, sorry, you're too young, kid. So you can see here the use of the else if statement. And first we check if we are 18 or at least 18. If this is true, this line here gets executed, and if this is not true, we will try to evaluate this line here, and if this is also not true, then the else part gets executed. So let's see what happens. And as you can see here, first we would like to order schnapps again, so this line here is executed. Then we print out the values of these two variables here, and as you can see here, both of them are true. We go here and check if this value here is true, and if this value here is true, this line here is executed. And I would like to point out that as soon as the first evaluation within a if block is true, then the rest of the if block is ignored. So only the first evaluation which is true gets executed. Because you see here, this value here is also true, so we are also 16, but this line of code gets not executed. So this is really important. Only the first comparison which is true, or the first condition which is true, gets executed. And here I have some bonus example for motivated students. And yeah, if you would like, you can look at them. Now we will talk about our very first complex data type, namely lists. Lists are used to store multiple elements or values in a variable, and you will use them a lot because they are really, really handy. So you can define a list as follows. So we declare a variable which is called drinks, and we can define a list with those square brackets, and within those square brackets we can type in the elements which we need to separate by a comma. So in this case, the list contains 3 elements, or more specifically 3 strings, which are all separated by a comma. So we have beer, schnapps and cola. And we can also print out the elements of this list using our print function. And we can also access the elements within those lists using a zero-based index. And zero-based simply means we start counting at 0. So the first element is accessed via a 0. So for example, if we want to access the first element in our drinks list, we just need to type drinks followed by the square brackets and the index of the element. And as already said, the first element is accessed via the zero-based index, so we need to type 0. And with this code, we can access the first element in the list. And if we want to access the second element in the list, we need to increase our index. And the second element is indexed by 1. And with this code, we access the second element, namely Schnaps. So again, a short example here. Here you see the list of drinks, which I would like to order. You can see here I have the square brackets. And within those square brackets, I separate the elements which I would like to store in the list with a comma. So here I have 4 elements, namely a string beer, string water, string schnapps, and string cola. And then I can print out the list using the print function. And as you can see here, it simply prints out. And as I have shown you, you can access the elements within a list using the zero-based index. And to access the element in a list, you need to do this also using the square brackets. So if you want to access the first element in the list, which is beer, you need to type in 0. If you want to access the second element, you need to type in 1, which is this. And if you want to access the third element, you need to type in a 2. So if we print those out, you can see here, using the 0, the first element got printed, using the 1, the second element got printed, and using 2, the third element in the list got printed. The last topic what we will cover today is loops. And at this point, I would like you to pause the video and get yourself a cup of coffee, because this topic is really important, and if you understand it, you have already mastered the first very big concept in programming. So it is really important for you to understand the concept of loops. So take your time, listen to it more often, and try it out. So what are loops? Sometimes we take it for granted the ability to instruct someone to repeat an action rather than needing them to perform each individual action. So let me give you an example. So imagine that 2 friends of you come over to your house for having dinner. And instead of telling your girlfriend or your friend, for example, set this plate on the table, then set this plate on the table, and then set this plate on the table, you simply say, set the table for 4 people. Or in other words, take yourself a plate and put 4 on them on the table. So this is basically a loop. And computers require very specific instructions to perform their tasks. So to repeat an action 100 times, it would require having you to write 100 lines of code to repeat the action. But fortunately, there's a way to tell a computer to repeat an action without writing a separate line of code for each repetition. And this concept is called a loop. So loops are used for repeated execution of code blocks. So in Python, there we have 2 types of loops. The first type are called for loops or counting loops. And basically with a for loop, you can iterate through each element in a list and repeat the execution of a certain code. The second type of loops, which is available in Python, are called while loops or conditional loops. And a while loop is true, or a while loop executes the code while a given condition is true. So while a given condition is true, repeat the execution of the code. We can then further control the execution of a loop using the following two commands. The first one is break, which ends the execution of a loop, regardless of the condition in a while statement or the current position in a for loop, or continue, which skips the remaining code of the current execution and starts with the next execution of the loop or the next iteration of the loop. Let's look at some practical examples. Here I have declared a list of drinks which I would like to order containing 4 elements. And here I use a for loop to iterate through each element in the list. And here you can see I have defined my list through which I want to iterate. And here I have defined a variable which will hold each element in the list. So for each drink in the drinks I would like to order, I'm going to print out the drink or the value. So if we execute this, you can see here that using this for loop here, we printed out each element in the list. And we can do the same using the range function here. So for example, for each element in a range, we're going to print out the number. So again, we have here a for loop and we will iterate through a range which will start from 0 until 10. And I would like to point out that the 10 or that the last value here, the end is always exclusive. So it will print out the values from 0 to 9. And again, here this is so to say my list or my range where we iterate through, and the variable count will hold each element within the range. So if we execute it, you can see here that it prints out all numbers starting from 0 until 9. Because I said this second value here is always exclusive, so the 10 is not printed anymore. And if we get back to our dinner example, for example, you can see here I have printed out 4 times that we would like to put a plate on the table. So put the first plate on the table, put the second plate on the table, put the third plate on the table, and so on. And if we would like to implement those 4 print statements with a loop, we can do that using a for loop, for example. So for each value in a range from 1 to 5, so we start at 1 and stop at 4. So this is always this value minus 1. So the end value is always this value minus 1. So it's exclusive. And then for each n in this range, print out, put the nth table or the nth plate on the table. And if we again execute this code block here, you can see that the output here is the same. And as you can see here, we only needed 1 line of code or two lines of code to repeat this action 4 times. And here I have a small bonus example for motivated students. You can look at it on your own. And as a side note, I will always upload the IPython notebooks here into the Teach Center so that you can try out those examples on your own. So let's now look at the continue command. Again, here I have my example where I have a list containing 4 elements of drinks which I would like to order. And then I again iterate through each element in the list, so through each drink in the list. And then we check if the drink is equal to water, then we continue with the next iteration. And if not, we just simply print out the value of the variable. So let's see what happens. And as you can see, the code printed out 3 elements, namely beer, schnapps, and cola. And as you can see here, the element water got skipped. And why did that happen? Because we executed the continue command at exactly this point in time where we reached in the loop the element water. So here we check if the current element is equal to water, and if this is the case, if this condition evaluates to true, then we continue with the next iteration. So at this point in time, if this condition is true, if continue is executed, all the rest of the code is skipped and the loop starts again with the next iteration. And that's why water is not printed out here. And here I have also a further bonus example which contains an if statement within a loop. To while loops, so here I have prepared a variable money which is equal to 9 and a variable called beer count which is equal to 0. And within a while loop, we print out how much money we got and how many beers we drank. And we repeat those while loop as long as the variable money is greater or equal to 3. And so in the first step in the while loop, we print out how much money we have and how many beers we got or we drank. And then at the end of the loop, we decrease the variable money by 3 and we increase the beer count by 1. And if we execute this, this code here, you can see that the while loop got executed 3 times. So the first execution, we got 9 euros and drank 0 beers. Then the money variable got decreased by 3 and the beer count got increased by 1. Then at the next iteration, we got 6 euros left and drank 1 beer. Then again, the money variable got decreased by 3 and the beer count got increased by 1, and which means money is equal to 3. And therefore this condition is still true, so money is still greater or equal to 3. Therefore this line got executed, which means okay, we had 3 euros left and drank 2 beers. And then again the money variable got decreased by 3, which means money is now equal to 0, and therefore this condition here is false and the while loop stops. And here in this example, again I have initialized money to 9 and my beer count to 0, and again I check, or in my while loop the condition is while my money is greater or equal to 3, repeat these steps here. So then the first thing what I do is I decrease my money by 3 and I increase my beer count, and then at the end I print out how much money I got and how much beers I drank. So my question to you is, what is the last output of this loop? So let's find out. And as you can see here, the last output of this loop is that we have €0 left and that we drank 3 beers. Yeah, so the difference between those two examples here is that we here first printed out the values of the variables and then at the end changed the values of the variables. And here we first change the values of the variables and then we print out the values of the variables. So for example, if we go through it, first our value of money is 9, and then within the loop we first decrease it by 3 and then we print it out. So the first print statement is when the value of the money variable is equal to 6. All right. And then the last example for today is with the break statement. So for example, imagine that we have €50 and drank 0 beers. And again, while money is greater or equal to 3, repeat these lines of codes here. And again, we first print out how much money we got and how many beers we drank. And then we check if we had drunk 5 beers, then we print out this emoji here. And then since we cannot drink more than 5 beers, we stop drinking beers and therefore we execute the break command, which will terminate the loop and skip all the rest of the code. So let's see what happens. As you can see here, first we got €50 and drank 0 beers, and then we repeat drinking beers until we drank 5 beers, and then we throw up and the loop terminates. So that's it for today's lecture. Thank you very much for watching.